Lightning. I mean, it's one of nature's most epic shows, right? This brilliant flash that just tears across the sky, and then that incredible, ground shaking roar. It's beautiful, but yeah, it's also pretty intimidating. So, have you ever really stopped and thought about what's actually going on up there?
It really does feel like it just comes out of nowhere, doesn't it? So how in the world does a simple cloud, something that looks so, well, cloudy, unleash one of nature's most powerful forces? Well, we're going to break it down.
Okay, so here's the game plan. We're gonna go inside the storm factory, look at the electrical imbalance, see nature's violent solution, figure out how it connects to the ground, and then, of course, the flash and the bang.
All right, let's dive right in. First stop, inside the storm factory. This is where it all begins, where all the ingredients for a lightning strike start to mix.
So this whole process gets started inside what's called a cumulonimbus cloud. Now, don't picture some gentle, fluffy white cloud. No way. This thing is a towering monster, and inside it's total chaos. You've got these super strong winds just whipping around water, ice, and hail, making them smash into each other over and over. And that constant collision, that's the key. That's step one. And all that crazy mixing and smashing around, well, it leads us right to our next part. A huge electrical imbalance. This is what really sets the stage for the big show. Think of it like static electricity, but on a cosmic scale. You know how you rub a balloon on your hair? Same idea. As all those particles collide inside the cloud, something interesting happens. The lighter little ice crystals, they lose electrons. That makes them positively charged, and because they're light, they get swept way up to the top of the cloud. At the same time, the heavier stuff, like hail, it gains those electrons, becomes negatively charged, and sinks down toward the bottom. So what you end up with is a giant battery just floating in the sky. Seriously. The top of the cloud is all positively charged, and the bottom is all negatively charged. This separation creates this incredible electrical tension. So, you've got all this tension building up. What happens next? Well, nature has a pretty violent solution. It's this powerful and honestly inevitable release of all that pent-up energy. It really all comes down to a simple idea. Nature it doesn't like imbalance. This huge separation of positive and negative charges, it's just not stable. The universe is always trying to find balance, and this situation is no different. Something's gotta give. And that something is lightning. That's all it is, really. It's just a super rapid, massive flow of electricity that jumps between the positive and negative spots to get everything back to neutral. It's nature just snapping back into balance. Now, this discharge can happen in a few different ways. You can have it happen all within one cloud, jumping from the negative bottom to the positive top, or it can jump between two different clouds. And then, of course, there's the one we all think of, the big one that goes from the cloud all the way down to the ground. But here's a cool fact you might not know. Most lightning actually never hits the ground. The vast majority of it happens up in the sky, either inside one cloud or jumping between clouds. It kind of just lights them up from the inside, like a giant, spooky lantern. Okay, but what about those really dramatic bolts, the ones that do hit the ground? Let's take a closer look at how that connection actually happens. It's a really fascinating process. That big negative charge at the bottom of the cloud, it actually repels the negative charges on the ground right below it. It literally pushes them away. So what's left on the ground under the storm? A strong positive charge. And that positive charge loves to gather on tall things. Trees, buildings, you name it. Eventually, the attraction between the cloud and the ground gets so strong, it just can't be contained anymore. An electrical path opens up and, zap, you get that massive strike. But believe it or not, that zap is just the beginning of the show. Now we get to the part we all actually see and hear, the flash and the bang. To get the flash, you have to first understand the heat. A lightning bolt is, well, it's ridiculously hot. We are talking about something that is up to 5 times hotter than the surface of the sun. Just let that sink in for a second. So when all of that insane energy gets dumped into a tiny little channel of air, it heats it up almost instantly. This superheating makes the air expand explosively, and it's that sudden, violent expansion of glowing hot air that we see as the bright flash of lightning. And of course, we see that flash almost instantly, right? Because light is just crazy fast. But the sound, it's created at the exact same moment, but it takes its sweet time getting to our ears. Which leads to a really good question.
If the flash is all about that expanding hot air, then what is thunder? What's that sound we hear a few seconds later?
Well, the answer is that the thunder is a direct result of that expansion. The air gets heated so fast and expands so violently that it creates a shockwave, a literal sonic boom. That's what thunder is. That shockwave travels through the air and eventually hits our ears. So the flash and the bang, they're really just two sides of the very same, very violent coin. Okay, wow. That was a pretty wild ride inside a storm cloud. Let's do a super quick recap of the main points. So, let's put it all together. First, lightning gets its start inside those chaotic cumulonimbus clouds. Second, at its core, it's all about electricity, a massive buildup of charges that has to be released to get back to balance. And finally, the insane heat from that release is what gives us both the flash of light and the bang of thunder. And that kind of leaves us with a final thought, doesn't it? If lightning is really just nature's way of fixing an electrical imbalance, it makes you wonder what other imbalances out there, I'm talking pressure, temperature, even geology, create such powerful and amazing results. Definitely something to chew on.